Okay, if you wonder, today we're going to go through topic 4x4. There are two main sections of 4x4, which is first of all the part on Snell's law and the second part on interference. Those are the two main chunks today. Very important chunk because this is going to link to 4.5, 9.2, 9.3, 9.4. So if you don't understand this, you better make sure you understand everything. Yeah, otherwise it's going to be an avalanche effect, domino effect. So let's go for the Snell's law. Snell's law not so much, it's the interference I'm more concerned with. Why? Because Snell's law you have done it before. Now in your secondary years, I'm sure that you have done sine I over sine R equals to N. I'm sure you have done this before. But the problem with this is if you were to look at I send a light from here to here. Now, if I call this incident and this is refracted, there is an issue over here, which means that if you take sine I over sine R, in this case, your I is actually lesser than your R, which means that this will be lesser than 1, which cannot be. So there is a problem over here. But this is not incident. Come on, let's face it, this is not incident, this is refracted, this is incident. So if you go by the true meaning of incidence, then you should call this incident. Otherwise, it's counterintuitive, right? It's like you invest money and then you earn money out of it. You call it investment and earnings. You don't call it. Correct. Agree. But is there a better way to understand this? Yeah. Exactly. So there is not even Ni. It's just N1 sine theta 1 equals to N2 sine theta 2. You don't even have to remember which one is initial, which one is final. You just need to make sure that you have region 1, region 2. You just substitute the refractive index and the angle that is associated in that region. And then you don't even need to know which one is incident, which one is refracted. You work it out by yourself.
Why did we learn this instead? Isn't that easier?
Excellent point. It's the same thing as asking why don't you learn F equals to dp dt in secondary school? Why learn F equals to ma? Hey, hang on. It's not correct. Why have you been teaching me the wrong thing? Yeah. Actually, this should be the one. Yeah. Then why don't you teach us relativity? Why teach us Newtonian mechanics? Come on. Some people are just not ready for it yet. So let's teach the easier ones and then we go on to the higher ones. Yeah. So it is not wrong. It is just more complete. Now the question is, how do you derive this? It is not in your IB syllabus, but I thought since you are a group of very enthusiastic young gentlemen and ladies, you'll be interested to know how this comes about. Yeah? That's a big assumption, I guess. Yeah. Now, sometimes you just have to assume that things are true and then you probably see what you... Hello, hi. This is your senior.
Hi, sir.
In case you wonder, this session is being recorded. Though. Yeah. Yeah, so do you have to say something to say?
Make a quick announcement.
Okay, can. Go ahead. You're being recorded, by the way.
Subscribe, Snell's law.
Yes, correct.
YouTube channel.
Hi.
You have 60 seconds. Go.
Okay, hi guys. We are from SRC, and so we just wanted to tell you to check your emails, your school emails.
Yes.
Yeah, because we just sent an email containing an invitation to this Wednesday's AGM. So I would suggest you guys come for the AGM because we'll be discussing a lot of SRC related things, which is very relating to you guys because you guys are in the ASP class.
Yep,
So
they are.
competitions, trainings, exco positions and all that. So pretty important. Most of your friends are coming, I think. So why not? Yeah. So it'll be from 3 to 3:30 at the IB Physics Lab.
Clear? Any questions do you want to...
You figure it out. Yeah.
There's
Just yeah, it'll be one of them. Just wonder.
Can you just in one sentence share with them what's the difference that SRC makes to the school?
Sir is waiting.
I can't do that.
No, it's fine.
We make research accessible to people.
Okay, that's important. Fair enough, that's important. Making research accessible to everyone. Yeah. They're not going to make you into a Nobel Prize winner kind of thing. Yeah. Probably set you on a journey. Yeah, can? So
So is this diffraction?
no, this is not diffraction. See what happens when you don't take physics. Thank you. By the way, how do you find out that I'm here?
Oh, we wandered along.
I see. You sure you didn't put a tracker on me? You sure you didn't put a tracker on me? Okay, bye. Okay, now what happened over here is that when the light goes in over here, from a less dense medium to a more dense medium, it bends towards the normal. Yeah, I hope you know that. This is bending towards the normal. Now, do you agree that if I have a wave front over here, as it enters this region 2, it will actually slow down. So it travels a shorter distance over here as this sweeps across. You can almost imagine this rod, this being a rod held by different people. So as they enter a muddy field, these people are going to slow down, and therefore the rod is going to turn this way. Yeah? You can almost like imagine a row of people holding the rod, and then these people, as they enter the muddy field, is going to slow down. So when these people walk faster, naturally the whole rod will start to turn. Okay? Now the time taken, the key over here, this is the key. The key in this whole derivation I'm going to show you is that the time taken for xy must be the time taken for AB. That means by the time this reaches here, this wavefront reaches here, this wavefront will reach here. So that they move together as a rod together, in a sense, wavefront. Okay, now let's take a look. This is going to be fun. So what you have over here is xy divided by the speed in xy equals to AB divided by the speed in AB. Still cool? Now, xy. Can you see that xy, if I call this theta r, this as theta I, can you see that this will be 90 minus theta r? Therefore, this is theta r. Cool? Therefore, xy can be re-expressed in terms of xb sine theta r. You see, the right angle triangle here. Still cool? Divided by the speed of light or wave in xy is actually the speed of light divided by n1, or n2, sorry. Still cool? Now, this is equals to the same rule, xb sine theta I over c divided by n1. Cool. Now, can you see that I can cancel this away? I can cancel this away. Therefore, you have n2 sine theta r equals to ni sine theta 1. Snell's law. Oh, the time has to be because they are the same wave run. So if there's the same wave run, the time taken for this must be the same as this so that they continue as one single wave run. If the time is different, then by the time this reaches here, this will be somewhere lagging behind. So it has to be the same time. Otherwise, there will be a disconnection. Okay? Yep. This one, you mean? From this one onwards, yeah? Okay, time is equals to distance divided by speed. Yeah? Speed is equals to speed of light divided by the refractive index. That's the definition of refractive index. Yeah?
When things are traveling at the speed of light, right, would xy be actually xy?
Oh, you're talking about time, length contraction? But length contraction only happens when you're talking about relative motion between two observers. So, and the two observers needs to move at a speed lower than the speed of light. So, what are you talking about? There's only one observer, which is us, observing the speed of light changing in different medium. So we're talking about time, length contraction. I think it's not the context to talk about. Length contraction is only when I take a meter rule and then I move relative to you, then you observe that the length changes. And yeah, and that speed that I move at is not the speed of light. Yeah, Ken? Cool. Ken? So yeah, okay with this, huh? So I think it's always good to know about why certain laws are true. And then you try to find out. Now, the next thing that I'd like to show to you is this thing that you have learned before. That is, as a consequence of that, if I were to have one medium denser than the other medium, say this is N2, this is N1. Now, what do you call this angle, people? There's a special name, come on, it starts with C. Critical angle, yes, correct. Excellent. So, if this is 90 degrees, so N1 sine 90 is equals to N2 sine critical angle. So sine critical angle is equals to N1 over N2, and sine critical angle is equals to sine inverse N1 over N2. Now in your syllabus in secondary school, N1 has always been 1. Yeah, N1 has always been 1. Yeah. By the way, do you know that there's this medium where the scientists claim to have discovered that they actually can get negative refractive index? Yeah. No, in order for you to be faster in speed of light, it has to be lesser than 1, but they got negative refractive index. I think, if I'm not wrong, what they realized is that if you have a medium over here, medium 1, medium 2, so basically you go like this. For some reasons, they claim that if this is possible on a wider scale, they will be able to design lenses, camera lenses and all kinds of lenses to microscopic scale. That means eventually all the optical system can be compressed into something really, really small. I don't know, probably Huawei has discovered it. You look at this, have you tried, I think I've actually shown my awe for Huawei's camera. This is not selling for them, but the 50 times zoom, have you tried it? You must go and try. You must go and try it. No, it's fine. So, okay, I'll share with you how amazing that is after I stop the video. So this is the critical angle. Equations are equations until you apply them. Then you know how to apply, and that's what I want you to learn. Okay? So let's learn how to apply. I'm going to give you a scenario, and you show me how to find the thing that I want you to find using what you have learned over here. So this is an optical fiber. This is n equals to 1.1. This is n equals to 1.4. This is n equals to 1, which is air. You send in a beam of light over here, and this beam of light goes in, and this beam of light goes here. So what I want you to find is this angle theta over here, theta x over here. Find theta x. State whether theta x is the minimum or the maximum angle for the fiber optics to function. Give it a try. Is this the minimum or maximum angle for the fiber optics to function? To function as it is intended for. I mean, fiber optics, how we remember that the light must bounce down the thing. Yeah, the light must bounce. So is this the maximum, is theta x the maximum angle or the minimum angle for the optical fiber to work? Yeah.